Every day, more than 400 million M&Ms are produced, nearly 5,000 pieces every second. But the process behind their thin, crispy, perfectly uniform sugar shell remains one of Mars's most closely guarded trade secrets. How can such a thin shell coat hundreds of millions of candies so evenly every single day? The answer lies in dozens of rounds of sugar coating, drying, polishing, and automated quality inspections before each piece reaches store shelves in more than 100 countries. M&Ms have even traveled into space aboard the Space Shuttle with astronauts. Join Mido Explained as we go behind the doors of one of Mars' most secretive factories. Behind these tiny candies is Mars Wrigley, one of the world's largest confectionery manufacturers and part of the family-owned Mars Corporation, which generates more than $50 billion in annual revenue. Today, M&Ms are sold in more than 180 countries and come in dozens of varieties, including peanut, peanut butter, almond, crispy, and caramel. While the fillings may differ, they all go through the same core production process. The idea behind M&Ms first appeared more than 8 decades ago, when Forrest Mars noticed soldiers during the Spanish Civil War eating chocolate coated with a hard sugar shell to keep it from melting in their hands. That simple observation led to one of the best-selling candy brands in the world. Today, Mars factories across the United States and Europe continue to recreate that same idea, hundreds of millions of times every single day, with dozens of production lines running around the clock. And it all begins with a single cocoa bean. Every M&M's candy starts with 3 core ingredients: chocolate, sugar, and milk. Peanut M&Ms include one additional ingredient: roasted peanuts. Together, Côte d'Ivoire and Ghana, 2 West African countries, produce about 60% of the world's cocoa, out of nearly 5 million tons harvested each year. After harvesting, the cocoa beans are cleaned and roasted at temperatures between 120 and 160 degrees C. As they roast, the outer shells crack open, the rich aroma of chocolate begins to develop, and the beans gradually turn dark brown. The roasting temperature determines much of the chocolate's final flavor. If the beans are under-roasted, the chocolate tastes flat and acidic. If they're roasted too long, much of its characteristic flavor is lost. The outer shells are then removed, leaving only the inner kernels, known as cocoa nibs, the raw material used in the next stage of the process. But cocoa nibs are still far too coarse. To become real chocolate, they are first ground into a thick liquid known as cocoa liquor, then blended with sugar, milk powder, and cocoa butter, before passing through a series of refining rollers that reduce the particle size to just 20 to 30 microns, about 3 times smaller than the diameter of a human hair, the point at which the human tongue can no longer detect a gritty texture. The mixture then enters the conching stage, where it is continuously mixed for many hours at temperatures between 50 and 80 degrees C. This process allows unwanted acidic compounds left over from fermentation to evaporate while coating every solid particle with a thin layer of cocoa butter. The result is chocolate that is smoother, more uniform, and richer in flavor. Every major chocolate manufacturer, including Mars, keeps its conching conditions as part of its proprietary production process. But even after conching, the chocolate still isn't ready to become the center of an M&M's. It must first go through one more step to control how the cocoa butter crystallizes. But even after conching, the chocolate still isn't ready to become the center of an M&M's. It first needs one more critical step to control how the cocoa butter crystallizes. Cocoa butter can crystallize into 6 different forms, but only Form V produces the glossy finish, crisp snap, and smooth melt that high-quality chocolate is known for. The chocolate is first heated to about 45 degrees until it is completely melted, then cooled to around 27 to 28 degrees before being gently reheated to 31 to 32 degrees C. This process leaves only the stable Form V crystals. Without tempering, the chocolate loses its smooth melting texture and can develop white streaks or patches on the surface, a phenomenon known as fat bloom. After tempering, the liquid chocolate is finally ready to be shaped. For milk chocolate M&Ms, the chocolate is deposited into small dome-shaped molds, forming the candy's signature flattened oval center. For peanut M&Ms, roasted peanuts are coated with multiple layers of chocolate until they are evenly covered. The chocolate centers then pass through a cooling tunnel maintained at approximately 0.5 degrees Celsius, where they harden quickly while retaining their precise shape. In just a few minutes, they are firm enough to move on to the most important stage of the entire production process: panning. This is the longest stage and the heart of the entire M&M's production process. The chocolate centers are poured into giant rotating drums. As the drums continue to spin, layers of sugar syrup and corn syrup are sprayed on in carefully timed intervals, allowing each layer to dry before the next one is applied. This cycle is repeated dozens of times and can take several hours to complete. If the shell is too thin, the candy can crack during transportation. If it's too thick, it loses the signature crisp bite that makes M&Ms so distinctive. Here's a detail that most people never notice. The 6 familiar colors are not applied randomly, and their proportions aren't random either. Mars uses a fixed color distribution, with blue making up the largest share at about 24%, while brown and red each account for roughly 13%. Even more interesting, blue wasn't introduced until 1995, after more than 10 million people voted for it in a worldwide Mars poll. During this stage, each batch is coated in only one color. Only after every color batch is finished are they mixed together in the correct proportions, ready for the final finishing stages. Once the sugar shell has fully dried, the candies move into another rotating drum for their final coat. Carnauba wax, a substance with a melting point above 80 degrees Celsius and widely regarded as one of the hardest natural waxes used commercially. Only an ultra-thin layer is applied, just enough to add shine, reduce stickiness, and limit moisture absorption. From there, the candies pass through a high-speed food printing system that stamps the white M onto each piece. An engraved roller coated in edible ink makes gentle contact with the surface of every candy, applying just enough pressure for the ink to transfer without cracking the delicate shell underneath. Because each candy's shape varies slightly, achieving perfect print accuracy across an entire batch is nearly impossible. The whole system runs at speeds of hundreds of pieces per second. Before leaving the production line, every candy must pass one final automated quality inspection. Industrial cameras scan each piece for color consistency, shape, cracks, and size, while metal detectors and X-ray systems help identify any foreign contaminants. Any candy that fails inspection is instantly removed from the conveyor by a burst of compressed air. Those that pass are weighed, not counted individually, before being packaged, which is why the color distribution in a bag rarely matches Mars's published percentages exactly. The bags are then heat-sealed, packed into cases, and shipped to warehouses before making their way to store shelves around the world. This entire process takes place in a network of massive factories across the globe. In Cleveland, Tennessee, a single 640,000 square foot Mars facility produces about half of all the M&Ms sold in the United States, along with the company's entire domestic supply of Twix, operating 24 hours a day, 7 days a week. In Haguenau, France, another Mars factory produces approximately 72,000 metric tons of M&Ms each year, supplying about 90% of the European market with fewer than 800 employees. Although M&Ms come in dozens of varieties, including peanut, almond, and crispy, they all follow the same core production process. The only real difference is what goes inside the candy. The 6 familiar colors haven't always appeared together in every bag of M&Ms. In 1976, amid growing concerns over artificial food coloring in the United States, Mars removed the red M&Ms, even though its recipe had never used the banned food dye. A college student in Tennessee was so upset that he started an entire campaign to bring the red candy back. It wasn't until 1987 that red officially returned, and Mars celebrated by sending him 50 pounds of all red M&Ms. Nearly 50 years later, color has once again become the center of attention. In response to growing pressure to eliminate artificial food dyes, Mars is preparing to launch a line of naturally colored M&Ms this August. However, blue and brown still cannot be fully reproduced. Natural blue coloring made from spirulina is too expensive and can clog the spraying equipment, so those colors are not expected until 2028. Thanks to that protective sugar shell, M&Ms also became the first candy to travel into space, flying aboard the Space Shuttle Columbia in 1981. More than 8 decades after they were first introduced, M&Ms remain one of the most carefully researched and continuously refined candies in the confectionery industry. A single M&Ms fits easily in the palm of your hand, yet behind it lies nearly a century of research and a production process guarded with extraordinary secrecy. But perhaps the most fascinating part is that even a candy this simple has never been immune to changing times. From the food coloring concerns of 1976 to today's race to develop a natural blue color, M&Ms has continually adapted to survive, even when every change risks altering the very identity that made it famous. And in many ways, that is the story of the modern food industry itself, where even the most familiar products must constantly reinvent themselves to keep up with a changing world.